In exercise 8.2, they give us the names of some alkenes, and we just need to draw these molecules. So let's start with A. We have 3-isopropyl 2,4-dimethyl 2-pentene. Always start with the backbone, and notice the backbone here is going to be everything that comes after the last YL. So if you're reading the name, you see the last YL, everything after that is the backbone. Notice that it includes that number 2 there. That's telling you where the double bond is going to appear. So in this case, our backbone is 2-pentene. The prefix is pent, and that means that we have 5 carbons. That's the prefix for 5 carbons. So 1, 2, 3, 4, 5. Now we're drawing this molecule, so we get to number it however we want. I'm going to number it left to right. So 1, 2, 3, 4, 5. The infix is En, and what that means is that we have a double bond. Where do we have the double bond? Well, this number in front tells us we have it starting on carbon number 2, so it starts on carbon number 2. Now, a double bond is connecting 2 different atoms, so what is it connecting carbon number 2 to? It's connecting it to the next highest number. So it's connecting carbon number 2 to carbon number 3. So there we have our 2-pentene. So that's our backbone. Now let's think about the branches. Our first branch is an isopropyl branch. Remember, iso means you have that sort of snake's tongue, and prop, that means 1, 2, 3 carbons. So that's our total branch. That's going to be coming off of carbon number 3. So we have that snake's tongue with 3 carbons. Notice there's 3 carbons in that branch. So isopropyl. Okay, that's that branch. Next we have 2 branches. Each of them are going to be methyl groups. Meth is the prefix for 1 carbon. So each of these branches is going to have 1 carbon. One of them is going to come off of carbon number 2. The other methyl group is going to come off of carbon number 4. And so this is our molecule. We have 3-isopropyl, 2,4-dimethyl, 2-pentene. And so that molecule there will be the drawing for that name. Okay, let's try B, 4-ethyl 2-methyl 2-hexene. Start with the backbone. Backbone is what you have after the last YL. So you're reading it. There's your last YL. Everything that comes after that is the backbone. So here that's going to be 2-hexene. And notice that the 2 is part of the backbone. It's going to tell you where the double bond is. The prefix we have here is hex. And so that's the prefix for 6 carbons. So we'll have 1, 2, 3, 4, 5, 6. Now we're drawing this molecule, so we can number it however we want. I'm going to number it left to right. So 1, 2, 3, 4, 5, 6. The infix En is telling us that we have a double bond. Where do we have it? At carbon number 2, the number in front of the backbone, immediately in front of that backbone name. So it's starting on carbon number 2, but where does it go? It always goes to the next highest number. So if it starts on 2, it goes to 3. So we have a double bond between carbon 2 and 3. It starts on carbon 2. All right, now let's think about the branches. Our first branch is going to come off of carbon number 4, so this one. The prefix for the branch is F, and that means we have 2 carbons in this branch. So off of carbon 4, we'll have 1, 2. So that's our first branch. Next, we have another branch coming off of carbon number 2, so it's going to be coming off of here. The prefix is meth, that means there's only 1 carbon. So we're going to have a 1 carbon branch coming off of carbon number 2. And that's our molecule. We have 4-ethyl, 2-methyl, 2-hexene. Okay, let's try C. So in this case, we have 1,2-dimethyl cyclobutene. Now, notice they don't give us, if you're reading this and you're trying to identify the parent chain, reading, oh, here's your last YL, so that means your parent chain is cyclobutene. Now, in the case of cyclobutene, they don't give you a number for where the double bond starts, because this is happening in a ring, right? You see this cyclo here, you know it's happening in a ring. Wherever you put the double bond in the ring, where the double bond starts will be carbon number 1. You're going to number the ring to give the double bond the lowest number. So because no matter where you put the double bond, it will be carbon number 1, you don't have to say where the double bond is. It's implied it's on carbon number 1 to give the double bond the lowest number. So if our backbone here is cyclobutene, remember cyclo means you're going in a ring, bute is telling us that we have 4 carbons. 4 carbons in a ring looks like a square. The infix, En, is telling us that we have a double bond, and the fact that there is no number in front of the parent chain is telling us it doesn't matter where the double bond is. No matter where we put it, the molecule is the same. So imagine if we had put it on the bottom. Well, it's the same molecule, just rotated. What if we had put it on the left? Same molecule, just rotated. What if we had put it on top? Same molecule, just rotated. So anywhere where you would have put the double bond would have given you the same molecule, because these are 3-dimensional molecules that can move in space. So that's our backbone. Now let's think about our branch. Well, we have 2 branches. They're the same type of branch, though. Now, just so that we have some clarity, let's number this. If you number this first carbon number 1, notice number 2 has to be the carbon at the other end of the double bond. Number 2 could never be over here. It has to always go to the other end of the double bond. So that's 1, 2. And we have 3 and 4 going clockwise there. So off of carbon number 1 and 2, so that's going to be off of here and here, we're going to have our branches, and the prefix for these branches is meth. That means that there's going to be 1 carbon in the branches. So 1 carbon branch, 1 carbon branch. That is 1,2-dimethyl cyclobutene. So hopefully this gives you some sense of how you can take the name of an alkene and draw, like Michelangelo, the beautiful structure that it has.